Okay, welcome back. So hopefully we've all got our answers for what's the probability of getting 2 heads and 8 flips. So obviously we don't need to talk too much about this, but we'll go through it anyway. Remember that for you to have a binomial distribution, several things have to fall into place. Firstly, you've got to have a set number of trials. That's happening here. You have to have a clear success state and failure state. I'll define success to be a heads, a failure to be a tails, and the probability for each is about 50-50. Actually, it's exactly 50-50. So all of this falls into place nicely. We do have a clear binomial distribution here. Also, the formula, if you forgot it, which I cannot blame you for, you have n factorial divided by x factorial, n minus x factorial, p to the x, q to the n minus x. So we do those substitutions, we run those numbers, and it finally comes out to be about 11%, 10.9375%. And that's how we can get that. If you need to review factorials, by all means do so. But this is now, remember, just a way to find the binomial distribution or to find a value under a binomial distribution. It's not the only way. Well, it's the exact way, but anyway. Now, let's talk about the normal approximation. First of all, I'm going to get mu, which is my mean expectation, which is NP, and I'm getting 4 for my NP value. Sigma is the square root of NPQ. I substitute N and P and Q. Those multiply together, take the square root. I've got about 1.41. Of course, I'm writing more decimal places here. This is an ongoing discussion that I'm having with several students. Whenever it comes to working with Pearson or working with WebAssign, or just working in general, to be honest with you, you don't want to round off more than you should. I always personally like to carry with me a few extra decimal places until I get to the end, and then I will round heavily. But I digress. I've got my mu value and I've got my sigma value. I have my mean and my standard deviation. What I'm going to do now is find the z-scores for 1.5 and 2.5. And some of you might be saying, well, I thought we wanted 2 heads. I thought we wanted 2 exactly. Well, under a binomial distribution, that's exactly what we did. For the normal approximation, this is how we do that. To find 2 successes on a continuous curve, we take all the numbers that would round up to 2 or round down to 2. So that's going to be everything between 1.5 and 2.5. So we first find the z-score for 1.5, which comes out to be 1.77 negative. We do it again for a value of 2.5. That's going to be negative 1.06. I do a couple of lookups and take the difference there, and I'm getting a region, area, proportion, all of those things, of 1.062. So that's a 10.62% chance, according to the normal approximation, which is honestly pretty good, pretty accurate, given the fact that the actual value under the binomial curve, or I keep calling it a curve, under the binomial distribution is about 10.9%. Here we've got 10.6, it's actually 10.9%, pretty close, pretty close. And finally, to talk about technology, we can do it with tech as well, right? You can find the normal dist with mu comma sigma. So you can run those numbers and get the normal approximation between 1.5 and 2.5. Also, there is binomial dist, where you would put trials comma probability of success, and you can do pretty much the same thing in Desmos or Excel if you're feeling fancy for any sort of binomial approximation as well. I've got a link here. I'll share that on our drive. So the last question to ask is, well, why were they not equal? Why is there a discrepancy here? And the reason is simply it wasn't stable. There wasn't enough samples, right? If I did NP and NQ, those values aren't bigger than 5. Not good enough. All right, so we'll do another example in the next video. See you then.